Okay, so today we're going to talk about compound events, and we're just going to talk about like how many options we would have. These are a little bit more complicated than yesterday, but the way to solve them is still pretty easy. We don't deal with any fractions today, so that's pretty exciting. So here's an example of a compound event. Let me zoom forward here. All right, it says a car can be purchased in blue, silver, red, or purple. It also comes as a convertible or a hardtop. Use a table or a tree diagram to find the sample space for the different styles in which the car can be purchased. We're going to do both just so I can show you how both of these work. All right, I'm going to show you the table that they made. Okay, so there's the table that they made. They took a color blue, silver, red, and purple, and then they took the two different top options. So they said, okay, if I have blue, I can have a blue convertible, or I can have a blue hardtop. That's my only options for blue. Silver, I can have a silver convertible, silver hardtop, red convertible, hardtop, purple hardtop. So that's how you can make a table. That works perfectly fine for this one, but I also want to show you how to do a tree. So, same kind of thing. I'm lazy though. That's good enough for me on the tree right here. Blue, silver, red, purple. And then from there I have branches. I can have a convertible or a hardtop. I can have a convertible or a hardtop. Alright, so this is why I like trees, I think, because I can do lazy just like I put better down and it works. So how many different styles do we have here? Well, we have 8 different styles. 1, 2, 3, 4, 5, 6, 7, 8 different styles. All right, another way that some of you see this, those are my 2 different tops. I could also do a tree like this. I have 4 colors coming from both of these, blue, silver, red, or purple. I could do it that way and still end up with 8, 4, 4. I just think this one looks a little bit better. Okay, so you can do compound events like that and make a tree for all of your different options and branch them all out in crazy ways to help you figure out compound events. All right, here's the other examples of tree diagrams. These are kind of hard to see. This one says soda, and soda or juice is your first option. And then you have bagel, rye bread, or white bread, which is your second option on both of them. And then from there, you can pick cheese, pastrami, roast beef, or turkey. So you can see that this has tons of different options depending on what you want to eat, what you want to drink, what type of bread you want, what type of filling you want in your sandwich. So these are really complicated tree diagrams, but they're not really hard to understand. Just you have to repeat it every single time on each option. This one's one if I toss a coin 3 times, I could get heads or tails the first time, heads or tails the second time, or heads or tails the third time. So there's 8 different outcomes that I could get on that one. This one, there's 4, 8, 12, 16, 20. So there's 24 outcomes on this one. Sometimes on the map test, it will have you fill in tree diagrams. So it'll have this set up and it'll have blanks, and you've got to figure out what goes in the blanks just by looking at the other sections. So that's why I want you to see this. I'm not going to make you actually draw any today, but I want you to be aware of what they are. Okay, so there's a much easier way than doing all those tree diagrams. It's called the fundamental counting principle, which sounds really complicated, but it's actually really, really easy. Take the car example, so the one that this convertible or hardtop. All you have to do is you multiply your choices together to get the total possible outcomes. So we had 4 car colors and 2 top choices. So 4 times 2 gives me 8 outcomes. Okay, so let's do this one together. How many outcomes would a tossed coin and a number cube being rolled produce? So, excuse my terrible handwriting here. A toss coin, I have 2 outcomes whenever I toss a coin, heads or tails. Okay, whenever I roll a number cube, I have 6 outcomes. 1, 2, 3, 4, 5, or 6. So if I just multiply those together, my total number of outcomes, depending on what the combination could be, is 12. That's all you got to do. Hey. Yes. There you go. You're welcome. Okay, so try to do this one on your own. I'll do it with you. If you're stuck, picking a month of a year. How many months do we have in a year? 12. And then a day of the week. How many days of the week do we have? 7. So if I take 12 times 7, I get 84. So there's 84 different outcomes there. That would be a crazy tree diagram because each of my 12 branches would have 7 falling off of that. So that's why it's a little bit easier just to do this. All right. What would be the number outcomes for rolling a number cube and choosing a letter from the word number? What would my probability be for rolling a 6 and picking an M? So we have to do the first part first. What would the number of outcomes be for rolling a number cube? Well, we got 6 times, because the number cube has 6 sides, choosing a letter from the word number. Well, I have 1, 2, 3, 4, 5, 6 different letters there. So that would be 36 different outcomes that I could have. So then it asks, what is my probability of me rolling a 6 and picking an M? Well, there's only going to be one time that happens, so my probability would be 1 out of 36. Okay. Okay. Permutations. This is another thing that we have to learn. This is when the order matters. You can still use the fundamental counting principle. It just looks a little different. So I'm going to watch this video. I'm going to scooch it forward here so we can just see a quick example.
Scream Shop has 31 different flavors. If you want to buy a 3-scoop cone, there are 31 choices for the first scoop, 30 for the second, and 29 for the third, which gives a total of 26,970 permutations.
Okay, so go over here. The probability is written like this a lot. We saw that yesterday, probability of picking a B. Okay, permutations are written like this. The probability of N, R. N is the total number of options that you have. So, for example, in the ice cream problem, we had 31 flavors. So N is 31. And R is the number of ways to sort them. We wanted a 3-scoop with no repeating, so that's why we have our 3 here. So our probability would be 31, 3. So we did 31 times 30, because once we have pick a scoop, now we're now down to 30 choices. And then we did another one for 29. Okay, so let's say you have a playlist and it has 10 songs on it. You want to know the possible outcomes the first 3 songs would be. What would N be and R be in this equation? So if I'm going to set this up, P parenthesis, my N is the total number of options. Well, I have 10 songs, so 10 would be my N. And then R is the number of ways that I want to sort them. Well, I want to sort the first 3 songs, so R would be 3. Okay. So what is the probability of 10, 3? So in my calculator, I'm going to take 10 times 9, because it goes down once I get my first song. Then it goes down another one once I get my second song, times 8. So 10 times 9 times 8, I get 720 different options for my first 3 songs to be in different orders. Okay, kind of crazy. Okay, so you have 8 people racing. What's the possible outcome for the first and second place? So they already have this set up for you. So you know you're just going to start with 8 times, and how many times am I doing this? Just twice. So 7. So 56 different outcomes for people to get first and second place. And that's putting everyone together. Let me show you the actual picture here. So these are all the people. Of all these people, there's 56 different outcomes for someone to get first and second place. Okay, what's the probability that Haley's going to get first and Casey will get second? Well, there's only one place, I don't know why I just cleared all that could actually happen. Okay, so there's only one place. How many different options did we say we had? 56, so 1 out of 56. Okay, and that is it. You can go ahead and go to Go Formative. Remember, fundamental, you're just taking your options and multiplying them together. Permutations, you have to subtract one each time.